Hello everyone, welcome to SuMON student presentation. Today we have Advait Sriram of level 1 and he is going to present to us one of our fortnight worksheet problems. Let's get started.
My name is Advait Sriram and I am studying in 4th grade. Today I am going to present a problem from SuMON. It says, find the number of zeros at the end of 150 factorial times 121 times 125 times 24 times 27. Here I am going to divide this problem into two parts, 150 factorial and 121 times 125 times 24 times 27. The solution. First, let me give a short introduction in what is factorial. This is the factorial symbol, and if you take, for example, take 4 factorial, it is nothing but the product of the numbers from 1 till the number given. This is nothing but 1 times 2 times 3 times 4. Let's jump back to the problem. Your question now should be, how can we get a 0 in the end? It is any number times 10 or any even number times 5. I write 2n because odd plus odd is even and also even plus even is even. We know any number having at least 1 0 in the end is divisible by 10. Let me use the concept prime factorization. 10 is nothing but 5 times 2. 5 is nothing but 5. So, we got 5 times 2 is what gives us a trailing 0, which is nothing but a 0 in the end. Next, we simplify this problem to find the number of pairs of 2 and 5 in 150 factorial first. Let us go into the number of 2's first. So, let me write the first thing, numbers of 150 factorial. 1 times, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8, all the way till times 1 first. So, 2 is 2 to the power 1, 4 is 2 to the power 2, 6 is 2 to the power 2 times 3, and 8 is 2 to the power 3. It goes on and on. For every even number, there will be a factor of 2. We have lots of 2's now. Why do we need to worry about? We have to only worry about the 5's because the number of 5's only occur once in 5 numbers. Let me write the first few multiples of 5 below 150. 5, wait a minute, 5, 10, 15, 20, 25, 30, 35, 40, and all the way to 150. This is 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, and all the way till 40, it is 5 times 8. Here, let's count the first groups of 5 which we have. The numbers I'm circling. This 5, and note that we are not counting the other 5 in 25. For 30 also 1 and 40. Here, what should we do? To find the number of 5's in 150 first, we divide 150 by 5. It is 30. So there are 35's in first. You see that we have one more 5 in 25 which we have to include. And let me mark these numbers 75 and 125 in between. I'll take a different color. Let me list the first few multiples of 25 now. 25, 50, 75, 100, 125, and 150. So, 25 is 5 times 5. 50 is 25 times 2. Same way for all the numbers. Note that for the first one, 5, we already did it in counting the first 5 as you see over here as circle. Now we are worrying about this 5. So what we do? Again, same way, we divide 150 by 25. It is 6. The 6 more 5 we get in this group. So let us move on to the third one. And note that 125 is 5 times 5 times 5. The first 5, as we know, is counted in pairing, in grouping of 5s. The next one is counted what we did now. The third one is what we are going to count now. 125. And that's all. We can't go anymore because the next one will be 250. And it is more than 150. So we do 150 by 125, which is 1. Now what do we get? Yes, we get 35 in first plus 6 5s in the next, while factoring in 25, and the last 5 in factoring in 125 plus 1. We get 37 files which we have found now, and we can match all these 37 files with 37 2s, as we have lots of 2s in 150 factorial. In this part, we get 37 trailing zeros. The next part is 121 times 125 times 24 times 27. Let's prime factorize all of these. 11 times 11. This is 5 times 5 times 5. This is 2 cubed times 3. And this is 3 times 3 times 3. So, we already know 5 and 2 gives us a trailing 0 or a 0 at the end. Here we have 3 5s. 3 5s which we have to match with 3 2s to get 3 more zeros. We have 3 2s over here. If you don't want that, we have lots of 2s left in 150 also. We can use either of them. But still, we are needing 3 2s to match with 3 5s. We get 3 more trailing zeros now. So in the first part, we got 37 trailing zeros. In this part, we are getting 3 more of them. Adding them, we get 40. And therefore, we solve this problem. The answer is 40 trailing zeros. We solved this problem using prime factorization, a very important and huge concept which we used in this problem. It was found by Carl Friedrich Gauss, and it helped us a lot too. Thank you.
I hope you enjoyed the solution. Join us to solve more intriguing and advanced and intricate mathematics, which not only involves Olympiad style mathematics but also some activities that engage the children and their mind into beautiful mathematics with hands-on experience. We will meet in the next SuMON student presentation. Thank you everyone. Bye.